What's up guys? Today we're going to take a look at Qubes OS. I've been messing around with it for a couple of days now, and I know many of you have been asking me to cover it for many months now, so here it is. And for those of you that don't get the hype, you're like, oh my gosh, what is Qubes OS? I've never heard of it. This is yet another desktop Linux distro, but with a twist, okay? It's a little bit more interesting and unique than all of those Debian stable, just works desktop clones, because Qubes OS is a reasonably secure operating system. And we can take a look at some of the endorsements that it has. Edward Snowden, he's probably the guy that made Qubes OS really popular because he uses it as his daily driver. And he says if you're serious about security, Qubes OS is the best OS available today. It's what I use, and it's free. And not only is it free as in price, but it's also built with free and open source software. So Edward Snowden probably has one of the most severe threat models out there. He literally has government agencies targeting him directly, and Qubes OS is what he's using to protect himself digitally from that threat. And Qubes OS does that by providing very well implemented and very easy to use compartmentalization. So the problem that Qubes OS is really seeking to solve is the fact that most of us have multiple digital lives. So you probably have a work life, and so you have a work account, work accounts that are associated with that, things like email and cloud accounts for various portals. And you probably have data that's associated with that too, spreadsheets and Word documents. And you don't necessarily want that stuff to intermingle with your school life because you have specific data for that and you don't want things getting mixed up. And you probably also have a personal digital life. So that would be things like your social media accounts, your Netflix accounts, and you might even want further compartmentalization of your personal life. Maybe you have a gaming account, a Steam account, or different game profiles and things like that that you don't necessarily want interacting with your personal Facebook account. So pretty much everyone out there has all of these different digital profiles. How do you keep them all separate? Well, one thing you might do is just use browser profiles. This is a feature that's built into pretty much every modern browser, and they are pretty effective because most of the things that people are doing these days are in the browser. In fact, for most people, their operating system is basically just a bootloader for Chrome or Firefox or whatever browser they're using. But there is some data and some things that are not in the browser for some people. Well, actually for a lot of people, saved pictures, saved videos, things like that. It's not actually going to be saved in your browser. So how do you keep that data separate? Well, maybe you'll create different user accounts within your operating system, or you might even take things a step further and boot different operating systems for those different digital lives. So you're going to dual boot, triple boot, quad boot, however many operating systems it takes, or you could take things to the ultimate end and get different devices for those different digital lives. But each of those methods of separation has its downsides. The main downside is that none of them are seamless for switching between those digital lives. At the very least, you're going to have to be switching user accounts, which that's not very seamless. And also, if you're only using user accounts for separation, if one of them gets infected by malware, there's a good chance that the whole operating system is going to get taken over, so it's not really that effective means of separation. And the same deal could also happen if you're booting multiple operating systems. Again, you're going to have to reboot, so that's not very seamless. And the ultimate end, using different devices, is really inconvenient because imagine traveling with 5 laptops. It's not going to be very easy to do that. So Qubes OS lets you have these different digital profiles at the same time, and it lets you keep them separate with virtualization. And they also provide an optional Unix virtual machine to you as well. You can use that as another cube. In fact, I'm just going to start calling the virtual machines cubes because, well, that's what we call them on Qubes OS. So if I open up my Cube Manager, which you can kind of think of as a task manager for different cubes in Qubes OS, things are going to start to make a little bit more sense. So here we have DOM0, which in my case is Debian-based. If we go back to the website, yeah, by default, things are going to be Fedora-based on Qubes OS. I just chose to make things Debian-based by default instead because I'm a little bit more familiar with Debian than Fedora. But I do have the Fedora 36 template on here as well, so if I wanted to, I could create new cubes with this Fedora template. Now, one thing that you're probably noticing is all of these different cubes over here, that's what all of these are different colors, or at least they're in different categories of colors. So let me try to explain that real quick. Red is untrusted, or this is the lowest trust level, and this is generally going to be cubes that you want to keep very, very isolated, and you don't want to give them very much access to the rest of your system. So a non-Unix, right? Your Unix virtual machine that you're going to, and I think this is actually maybe an amnesic one, so like when you restart it, it doesn't save any data. Not 100% sure about that, but basically those kinds of machines are the ones that you want to be red, that you want to be restricted. Same thing with sysnet, which I'm going to talk about in a little bit. And then we've got gray ones. So these are going to be your templates. You know, your templates are trusted because, well, you're not even really booting into those. The templates are just things that you're going to create new virtual machines based off of. Because another general deal with Qubes OS is that none of these cubes, virtual machines, you know, those words are interchangeable here. None of these are really going to last forever. Because the whole idea with Qubes OS is if someone's really trying to get you, especially if it's a state actor, right? If it's an alphabet boy or an alphabet agency that's after you, they're going to get you eventually. They're going to compromise one of these cubes. So they're meant to be disposable. All of them are meant to be thrown away. That's why you never actually boot into these templates. They're completely isolated so that when, not if, but when one of those cubes gets compromised, because again, we're assuming that, you know, whoever is using this is like Edward Snowden, they literally have the alphabet boys after them. When it gets compromised, you can just poof, create another one based off that template that's fresh, and that O-Day malware that they use to compromise your VM is gone. Hopefully, it's not O-Day malware that's also able to jump the hypervisor. And then you've got the personal cube, which you may have noticed this is a Mozilla Firefox instance, or a Mozilla Firefox that's open inside of a personal cube. If I were to open up another one, like let's try, why don't we do Tor from a non-Unix? And it's going to take a little while to start up because it is literally starting up a virtual machine and then it's starting up the Tor browser. So you can see that sysunix has started. And, oh yeah, I got to go through this whole rigmarole because I haven't done that already. All right. So now you'll see this one is red. So that way you're not ever going to get confused. There's no way, I mean, you would literally have to be, I guess, you know, colorblind and, you know, really not paying attention to end up confusing personal data with something that's untrusted, because untrusted is going to be red and then personal is going to be yellow. And if we go back into the Cube Manager, if I were to spin up something for work, that's going to be blue. Now, the next thing I want to point out to you is this column here, NetVM, because this is where the isolation of Qubes OS and the security that it provides to you really impressed me. So you'll see over here under NetVM, all of these cubes are going to say either NA, and if they also say NA or if they're blank under the IP section, then that means that that particular cube does not connect to any network. So DOM0, which is basically this here, like DOM0 is essentially your hypervisor. If I open up this terminal emulator, this is DOM0 as well. So this is sort of the top level that's managing everything. It does not connect directly to any network. And also DOM0 does not connect directly to any USB peripherals. If you try to connect USB storage, I think there's some ways to override it, but by default, it's very, very difficult to connect a flash drive or some type of external USB device to DOM0. And that's also the same thing with the vault, which is basically meant for you to keep data inside that you want to be isolated from other virtual machines, and you want it to be isolated from the network because it also doesn't connect to the network, and you want it to be isolated from USB peripherals because it doesn't connect to those either. So that explains what's going on with those, and then you'll see that all the rest of these, they're either connecting to sysfirewall or they're connecting to sysunix, but if we take a look at the sysunix cube, we see that that's actually connecting to sysfirewall. And then if we take a look at, where is it here? The sysfirewall cube, this is ultimately connecting to sysnet. So these here, sysfirewall, sysnet, sysunix, these are all separate cubes themselves. Now, let's get a better picture of how it works here on Qubes OS. So you can see that sysnet VM, this is the one that has connections, that has access to your Wi-Fi and to your Ethernet. This is the only virtual machine that's connecting directly to these peripherals. So the way that your network communications are working is, of course, everything's coming in through here. It has to go through the sysnet VM, then it goes through the sysfirewall. That's on a separate VM. So if this were to get compromised somehow, which it has very, it's untrusted anyway, so it's going to be really easy to refresh this. If it gets compromised, it's not going to be able to compromise the firewall unless somehow it's able to jump the hypervisor, which if it's able to jump the hypervisor, then everything is screwed. But we'll talk about why this is a pretty secure hypervisor in a moment. And then your app VM, so like this would be personal, or same thing if you were to bring up a work VM, whatever, this is going to go and connect to that firewall. So there's two levels of separation here to connect to your network when it comes to a virtual machine. And then if you're running something in Unix, there's even more. So Unix, I've shown this before on KVM because you can also do Unix and KVM. You have a separate virtual machine that acts as a Tor gateway. And then you have the Unix virtual machine, which Tor is running in here. That's the same thing that's going on here. All of the network, the entire network stack for this virtual machine is sent through the gateway. So that's kind of acting like a router for it. Then all of that's going through this firewall VM, and then it's going through sysnet. So then you have 3 virtual machines of separation for the network whenever you're using Unix on Qubes OS. And then here on the Qubes website, they also have a pretty good example of how you would use the vault. So here you can see that KeyPassXC is kept within the vault VM because this is a very reasonable way to store your password manager. You really don't want your password manager to be connected to the network or to be connected to external storage. There's no real reason to do that. And in Qubes, there actually is a shared clipboard. So let's see, I can probably pull up the vault and let's see, bring up the terminal, and maybe I'll just install KeyPassXC to show you guys how that works. All right, so I've got my KeyPassXC set up here inside of the vault, and I can demonstrate to you guys how the shared clipboard works. So, like I said, you can't connect the vault to any network, you can't connect any USB storage devices to the vault, but you can still get what you actually need as far as KeyPassXC is concerned out of the vault, which is access to the clipboard. So the way that you would do that is first we can copy the username with Control B, and then I can do Control Shift C, which you can see that copied 9 bytes to the global clipboard. So now I can go into any other cube that I want to. So why don't we do it over here? Actually, no, let's do it not in DOM0. Let's do it over here to a disposable terminal. Or I guess I could just do it here into the Tor browser. Do that instead. So you want to Control Shift V, which is going to paste it into here, and then Control V to do a normal paste. And this just copied the username, test user. All right, so now why don't we go into a new tab, and actually maybe I'll post it here. Let's do the password. So let me see, I think that's Control C and then Control Shift C. Yep, so that copied 32 bytes to the global clipboard. Then we'll come over here, and then we're going to Control Shift V, and then I think it's actually going to be Shift Insert since I'm in a terminal. Boom, yes. So it just copied, this is a super secure password, JK Lamau. And we can also do the same thing with any custom text. So we'll just edit entry, and then we'll copy all of this stuff here. And we'll do Control C, so that copies it into the Vault Qubes clipboard. Control Shift C, that shifts it up into the global clipboard. And then why don't we take this and put it over here? So Control Shift V brings it down into this clipboard, and then Control V, paste it into the URL bar, or whatever input we were in. So there you go. Very seamless, very easy way. I mean, yeah, it might take a little bit of getting used to because it's an extra couple of moves, but it's not a super complicated way to copy data out of KeePassXC that's in a totally isolated virtual machine, and going to be very, very difficult for anybody to get their hands on that. Now, all of this virtualization is provided by Zen, which is a Type 1 hypervisor. Now, those of you using Linux, and especially if you've been doing virtualization on Linux with using a Linux host, you're probably familiar with KVM, which is able to turn the Linux kernel itself into a Type 1 hypervisor with the same capabilities as Zen, and in a lot of cases it actually delivers better performance than Zen does. So KVM is the new kid on the block, and a lot of companies are actually leaving Zen in favor of KVM. And I guess that's because they're getting more efficiency out of KVM instead of Zen. But Qubes OS is sticking with Zen because it ultimately is a much simpler hypervisor compared to the entirety of the Linux kernel. And when it comes to security, simplicity is much more important than performance or memory efficiency or any of the other advantages that KVM might offer over Zen. Zen is more of a thin hypervisor, as they put it here, than a fat hypervisor, which would be the whole Linux kernel. So when it comes to the security, I really do think that, well, this is a reasonably secure operating system. In fact, I think it's going to be the most secure operating system in the world. And even if there is something out there that's better that I just haven't heard about, or if there's something eventually that's going to be created that's better than Qubes OS, I bet that it's going to be designed in a very similar way to Qubes OS. Maybe it's going to use a different hypervisor, but it's going to basically follow the same model of just virtualizing and isolating everything, virtualizing the network stack to its own virtual machine, virtualizing, because here, if we look back at how this is really working, so you have network cards that goes, or no, this is a video card and like your monitor peripheral, that goes to a display manager VM or a GUI VM. Your network goes to the sysnet VM. All of your USB stack, that's all your peripherals. Anytime you attach an external hard drive, that goes to the USB VM. And then this goes into separate VMs that themselves are separated based on whatever task you're doing at the time. And then not if, but when one of these cubes, one of these VM instances gets compromised, you can just spin up another one with your templates, whether it's a Unix template that you need or a Unix cube that you need, or a Debian 11 cube, you can do that, or you can do a Fedora cube, and I think there's also unofficial ones. Like I said, I've only been messing with this for a couple of days, but as they show in the on their website, you can have like a Windows 7 template VM, so there's a whole lot of options for running different operating systems within Qubes OS. Now, there are some downsides to running Qubes OS that I think you should know about. Number one is if you're trying to use NVIDIA cards, it can be a little bit difficult. NVIDIA does not play well with Qubes OS, and that's kind of the deal with most Linux-based systems. So if you boot from USB, you aren't going to have any video on NVIDIA cards past grub, and that's actually the reason why I'm currently running Qubes OS on my old desktop, because this has an Intel 4790K CPU and that has integrated graphics, so that's what everything going on here is. Hopefully the video doesn't end up being too laggy because of that, but I think a 4790K can handle, browsing with a few tabs open in 1080p. But my Threadripper desktop, all that has for video is 2 NVIDIA cards. And of course, the Threadripper CPUs, those don't have integrated graphics, just 64 threads and 80 PCI Express 4.0 lanes. I know, boo-hoo, first world problems. So that's something to consider if you're running NVIDIA cards. Qubes OS, you might not even be able to install it. You might have to, what I might end up doing is installing the drivers into here, because as you can see, this post here more or less has instructions to do it, or I think this guy's asking for help with doing it. So I think it is possible to get NVIDIA drivers running for just specific cards. So I'm gonna have to do a little bit more research and see if they do work on my cards. Or better yet, as I'm sure several of you have probably written in the comments already, just get an AMD card, because AMD cards are way better on all NIC systems, BSD, macOS, Linux, of course. They're all going to be way better because of NVIDIA's bullshit when it comes to their drivers. And I think GPU pass-through is also another thing that's a little bit more complicated to do on Qubes OS. In fact, it's actually not even officially supported. So it's another one of those deals, just like installing NVIDIA drivers, where you're kind of going off the reservation a bit. You're going off of what you're really supposed to be using Qubes OS for or doing in Qubes OS. So I guess you just have to weigh that with your threat model, whether it's worth it or not to kind of go against what's officially supported on Qubes OS in order to be able to do more with it. But yeah, these are just some of my initial thoughts on Qubes OS. I do think it is pretty cool. I'm going to continue using it, and like I said, I'm going to try to use it on my Threadripper, which is a machine that's actually built specifically to do virtualization, so it should be able to handle running Qubes OS a lot better. And maybe I'll do a side-by-side comparison one day of running many VMs with Qubes OS versus doing it with KVM, since I've already done that a little bit, and really be able to give you guys the pros and cons of each. But that's it for this video. Have a great day.